So, everyone, let's just quickly go through the steps that will help you solve any force problem in grade 11, grade 12, or even first year. So, when a force problem is presented to you, let's follow the following steps to systematically, which means we have a procedure or a routine or an algorithm to solve. Number one, decide if the problem obeys what? How are you going to decide that? Again, those are going to be word problems. How are we going to decide that? How are we going to decide if the problem involves first or second? Exactly. Depending on how the object is what? Is moving. If it's not moving, it's what? First law. If it's moving, cruise control, it's what? First law. If it's doing anything else, it's what? Second law. So if it's accelerating, decelerating, or turning. We're going to do turning at the end of this year. Okay. Second thing. Sorry. Decide if the problem also involves what? What do you think? Third law, you're right. What do you think needs to be in a problem for it to involve third law? Two objects doing what to each other? Colliding in contact. If you're only looking at one, then it does not involve third law. By the way, rarely I'm going to give you, most of the problems are going to deal with first and second. I'm rarely going to give you a problem that has what? Two objects in contact in it. Okay? All right. Sketch a motion appropriate FPD. Now, why do I like to call it motion appropriate? Because sometimes I'm going to give you things that move which way? How is my hand moving? No, just like as a line.
Straight line.
Horizontal. Or if I give you a horizontal or vertical motion, you just use what kind of a grid? Just a what? Just a regular XY. But sometimes I'm going to give you motions on what? On ramps. What do you do when you have a ramp motion? What do you do with your own grid? What am I doing to my head? Tilting it. Thank you. Yes. Whenever you have something moving on a tilt, tilt your head. So basically, tilt your own perspective. Yes. If you have a horizontal or vertical motion, use a normal grid. Use just an XY, regular math stuff. But if you have angled motion, then you should use a tilted grid. I don't think we're going to get a tilted grid today, but definitely tomorrow for sure. Again, I told you, this course is full of ramp problems, just like first year physics. First year physics is 50% of these ramps. Okay, all right. Obviously, if there is motion direction, if it exists, so basically if it's either any of the second laws, if it's decelerating, accelerating, or moving in a constant speed, if there is motion, you should choose that to be positive. Even if the motion is what? Slowing down. It's still moving that way. You still move that. So you still choose that way to be positive. All right. Okay. This is basically just a step where you just make sure that you have the equations ready to be used. On the side, write the mathematical formula for each force if possible. Okay. Can you remind me how many engineering forces we have done so far? 5. Okay. Was there ever an equation for F applied? Is there an equation for F applied, or is it just a number? Yeah, it's just how much force you put into the system. So there's no equation for F applied. Is there an equation for F tension? No, it's just how much tension is in the rope. Is there an equation for Fg? Yeah. Yes, F small g, of course. What's Fg small? Fg equals mg. Okay. Is there an equation for normal force? Nope. Depends how much you put, it gets pushed up. Is there a formula for friction? Aha. Those of you who remember grade 11 physics, how many kinds of frictions are there? 2. The first one is called what? Static friction. And the second kind is called what? Kinetic friction. Each one has its own equation. We haven't covered them today. We're going to cover them tomorrow. But those are all the equations you need in any what? In any force problem. Fg, F static, and F kinetic. That's it. No other equations exist for forces. Okay? Sorry. And then, okay, we're going to have to do at least one force on the diagram that's not going to be a good vector. Decomposition has to happen, folks. It has to happen. So decompose any forces that are tilted, and then finally look at each axis and apply the first law or the second law. By the way, each axis has to have one law applied to it. no axis would have both laws applied. It doesn't matter. Sorry, it doesn't make sense. You cannot have an object moving both uniformly and accelerating or decelerating at the same time. It doesn't matter. Sorry, it doesn't make sense. And obviously, if it's not moving, then good. It's Newton's first law. Done. By the way, everyone, just so you know, even when I tilt it, I still call them what? Yeah, because I still remember which one used to be what. Like, for example, like this. Horizontal pressure, right? If I tilt it, which one's technically still horizontal? This one, purple. And this one's purple. So I still call them horizontal pressure. Or y and x. Okay? Alright. So let's quickly do one single problem. That's not really all of these steps, but just a good beginning. Alright. First problem. Okay. You have a mass. You have a mass of 26 kilograms. Now it has how many forces acting on it from the outside, of course? How many? Two forces. One force is 38 newtons, directed north 24 east, and another force is 52 newtons, directed north 36 east, acting on it. The question is, what is the acceleration of that object? Okay, let's think about this. Do you know the mass of the object? Everyone, do you know the mass of the object? Yes, you do. How much? 26. The question is asking for the acceleration. What's the only Newton's law that has acceleration in it? Newton's what? Second law. What is it? So F net equals ma. Do we know the m? Can we calculate the F net? What do you think?
Yes.
Yeah, we spent a whole day calculating F net. Well, how do you do it? You just decompose the vectors and do what? Do trigonometry work. Then can you find acceleration? Yes, you can. You divide F net by m. You divide F net by the m. Okay, so let's do that. Okay, let's do the diagram. You already have it on the same slide, I think. Okay, so what was the first force? Come on. What was the first force? 38. Which direction though? North, 24 east. So I'm gonna, and you said what was the magnitude? 38. Okay, so everyone, I'm gonna go like this. 38. And you said the angle was what? 24. Now, what's bad about the way they gave me the second angle? What's bad about the way they gave me the angle for the second vector? It also was north what? Northeast. So if you're going to do it without changing the angle value, you're going to have to do something like this. Oh, sorry. Obviously, that's way too tilted. Just let me erase it. Sorry. Maybe like this. Yeah, I think that's good. And how much is it? 52. And how much is this whole angle now? Yeah, I don't think that's a good way to put the diagram. So what should we do? Instead of using that angle, which angle should I use for the second vector? The complementary, which is what? Instead of northeast, I'm going to use what? East-north. Exactly. I would rather do this one now. Perfect. How much is the complementary for, what's the other? Yeah? 54. 54. So I'm going to erase this. I don't need that. And we will reuse it, but in a different way. There we go. 54. Okay. How many bad vectors do I have? Bad. 2. Great. Let's show the decomposition. Come on. Decomposition. So I have a decomposition here and a decomposition here and a decomposition slightly above. Just make sure they do not perfectly line up, otherwise you might not see both. Yes, go ahead. Anyone who would like to ask? Ammar, how did you get the 54?
You did the complementary, so I took that away from 90.
The whole thing is 90, right? This part was 36. 36. Yeah, 36. So how much is? Oh, remember, it. By the way, if you use the 36, would you still be correct? Ali? Yes, you would. But then it would cover a part of the original one, right? It just looks bad. All right. So, what's up? Yeah.
Wait, if it's like 36 plus 24.
Yeah.
Sine was the 54.
Sorry, say it.
It's like 24 plus 36 equals 50 something. And 54 for the calculated is over 100.
You don't
No, no,
add
no.
up, the whole thing is
You don't add 36 and 24.
How like?
Oh no, this 24 has nothing to do with this one. This 54.
Okay.
Okay, this 54 came from the complementary to this part. Okay, yeah, nothing to do with it. Obviously, can we find the angle in between? Sure, we can. Add 54 to 24 and subtract from 90, but there's no need. Okay. All right. Let's do the F net on the x. All right. Oh, which directions are positive? Come on. We only have two directions in this problem: east and west, east and north. Nothing else is pointing anywhere. Positive, positive. Okay. So you have. Okay, so you have already like a part on the slide, like on the left of the diagram, and you also have a blank slide. So you have enough space to write the whole thing. So first, F net on the x, F net on the x equals. Obviously, both x values are pointing what? I'm pointing what? Positive. Good. So positive, positive. So positive, positive. Okay. Let's do the 38. Is that 38 sine of 24? By the way, this is the 38 is right here, just so you know. Is this sine of 24 or cosine of 24? I'm talking about this part, just this part. How many people say it's sine? It is sine. Why? Because this part is the same as this part right here, and it's opposite to 24. Good. So sine of 24. Oops, sorry. Sine of 24 degrees plus 52. But what's the 52 gonna be? Sine or cosine? Cosine. Look at what? Because it's all of that. All of that, and it's adjacent to 54, so it's cosine. So cos of 54. Nice. Equals. Can someone do the whole thing in one shot and tell me the answer? Come on. It should be positive, obviously, because everything is still pointing positive. So positive. Make sure your calculator is on degrees.
46.
Okay. Point one. How many people got 46? 46.1. Zero. So 46.0. All right. 46.0. In which direction?
Are you Indian?
Oh, great. Yeah, make sure you're on degrees. What'd you get?
I got 42. I got a bunch of it.
472. Way too big. Remember, you cannot have 38 with a sine times 52 with a cosine and getting a number bigger than the maximum addition of both of them. Because sines and cosines are decimal, they always bring things down. So,
Are you multiplying that?
no, addition between them.
Oh.
Addition. So what'd you get? 42.
Oh,
46.
46.2.
Oh, 46.2. Okay.
46.02.
02, so 0.
Yeah.
Okay, let's do the F net on the Y. F net on the Y. Do I really need to do a lot of work to know what the expression? Wallah, what's the expression?
38
Yes,
cosine
cosine,
sine.
and both of them are still positive because both of them are still pointing up. Nice. So, positive 38 cosine of 24 plus 52 sine of 54. Nice. Equals?
76.
Okay, Josh got 76.78.
70.
So let's just go with 8. Confirmation, just one more hand. Anyone? People are doing it, so no problem. In the north direction. All right. What's the step always after? Always. Say it.
Or like
Pythagorean and tangent. Okay. So F net as a full expression is the what? Is the square root of the squaring of both of these. Who's got this? Obviously, it has to be bigger than 76 because the hypotenuse is always longer than either of the legs, like the perpendicular legs. Anyone?
I got 89.5.
I think that makes sense. 89.5 in newtons. Okay, how about the angle? Since we always like to get the horizontal angle, we always divide the F net on the Y by the F net on the X. So the tan inverse of 76.8 divided by 46.0. This has got to be a tan bigger than 1, which means the angle has got to be bigger than 45 degrees. Right there. If your tangent is more than 1, your angle is bigger than 45 degrees. Like between 45 and 90. What's it, 60 something?
I got 59.
59.0?
0.08.
So 0.1. Done. That's it. But that's it only for what? For the what? For the F net as a vector. They are not asking for the F net. They're asking me to use the F net to find one more last thing. What are they asking me to find using Newton's second law? Acceleration. So I need to divide that vector by the mass, which is 26. So, come on.
The mass by
Exactly. So acceleration, everyone, acceleration equals F net as a vector. By the way, is mass ever a vector?
No.
No, mass is a scalar. So this is technically that over m. All right. Did we ever divide a vector by a scalar before? Remember kinematics? We did it a lot. When? Give me one of the equations in kinematics that was a definition of something by dividing a vector by a scalar. Come on, kinematics. The first few days of the unit.
the first.
Before kinematic equations. Come on. Yes, the velocity is what? Displacement over time. So we did that before. When I divided a vector over a scalar, did I put everything on top? Or did I push one part of the vector to the other side? Which part of the vector you never divide? The magnitude or the angle? You never divide the angle. You only divide the magnitude. So that's why I always like to write it like this. I used to have a habit of dividing both things. And you can't change the angle. So I divide the 89.5 newtons. And what's the angle? Since it's always got to be horizontal, it's got to be east-north, which is 59.1. And what's the mass? 26 in kilos. Obviously, you don't have to write units. I'm just doing it today. All right, let's do this. Okay, 89.5 divided by 26. What's the specific situation for the problem? 2? 2?
Yeah.
Okay, so 2 will be what? What's this to 2? 3.4. So 3.4 meters per second squared east. Well, it has to be then 59 degrees north. Okay, let's compare what they got. Yes. There we go. Three point four. But instead of east 59 north, they did what? I guess they wanted to keep it the same notation as the problem. Are both of them correct? Yes, they are. Done. That's it. Okay.